So, a very good morning to everyone. Society for Agricultural, Horticultural and Allied Sciences SAAHAS welcomes you to the 6th day of training program on precision farming. Precision agriculture in India is capable of bringing the next generation revolution to produce food security as well as rural wealth. Although it is in dawning stage in India but has a lot of adoption opportunities, an organized training structure can coordinate to implement precision agriculture and achieve sustainable agricultural production. In light of this, we are overwhelmed to have with us today Dr. Shivendu Pratap Singh Solanki. On behalf of the team SAAHAS, I cordially welcome you to this training session, sir.
Thank you.
Having done his BSc Horticulture from Vasantrao Nayak Marathwada Agricultural University, Parbhani, Maharashtra, MSc Horticulture from Dr. Y.S. Parmar University of Horticulture and Forestry, Solan, Himachal Pradesh, and PhD Horticulture from Punjab Agricultural University, Ludhiana, Punjab, and currently working as the Subject Matter Specialist, Center of Excellence Center for Subtropical Fruits, Department of Horticulture, Haryana. He has also been serving as the training head in the Indo-Israel project. In perspective of precision farming in horticultural crop, today our speaker will be specifically highlighting us about the farming practices pertaining to precision farming in horticulture. Now, I invite Dr. Shivendu Pratap Singh Solanki to enlighten us about the precision farming with respect to horticulture with his words of wisdom. Over to you, sir.
Thank you, Dr. Tamanna. Good morning, everyone. Today, I focus on horticulture crop, applied precision farming, especially for horticulture crops like fruits, vegetables, and other horticulture crops. You already studied the different aspect of precision farming in previous days. Now we are focused on horticulture crops. It's just a recall session for the previous lecture, I would just say. Then we start with the precision farming. Then precision farming, especially based on principle and technology to manage the spatial and temporal variability associated with the all aspect of agriculture production for the purpose of improving crop performance and environmental quality. Especially if we talk about precision farming, then why we need for precision farming? Because of increase the land degradation in India out of 169.7 million hectare out of 125 million hectare of the land are affected by the water, wind erosion alone. And depletion of water resources, socioeconomic need to enhance productivity per unit of land, water and time. Environment pollution because of increased use of fertilizer and chemicals. Precision farming is essentially in order to address the poverty alleviation, enhancing quality of life and food security in India. If we talk about aim of precision farming, then especially if we focus on precision farming, it's increase the production efficiency, improve production quality, more efficient chemical use, energy conservation, soil and groundwater protection, reduce input cost and environmental health. Then different technologies are also used in precision farming like remote sensing, geographical information system, global positioning system, variable rate technologies, crop scouting, yield monitoring and mapping, yield estimation, and nutrient estimation for different technologies. These are the some technologies which is basically used in precision farming: remote sensing, geographical information system, GPS, VRT, crop scouting, yield monitoring, and mapping system in different fruit crops and vegetable crops. Next. First thing is, if we talk about the remote sensing is the science of obtaining information about an object, area, or phenomenon through the analysis of data acquired by the device that is not in contact with the object area under the investigation. This is basically based on satellite data and other spectral imaging system for the estimation of data with the use of remote sensing. The next, then remote sensing is the art and science of obtaining information about the phenomenon without being in physical contact with them. You are already covered these points in the previous lecture. That's just as a recall session for just connected with the next slide or applied research with horticulture crops. Then application of remote sensing in agriculture, the cropped area, crop condition, climate, temperature, rainfall, and these are the some application related to remote sensing for estimation of data in different fruit crops or vegetable crops or any other crops. If we talk about geographical information system, next slide. Uh, it is also brain of precision farming system. It is the spatial analysis capabilities of GIS that enable precision farming. In other words, we say powerful set of tools for collecting, storing, retrieving, the transferring, the displaying spatial data for the real world. If we talk about global positioning system, it is also satellite-based radio navigation system that is capable of providing extremely accurate worldwide 24-hour three-dimensional location data like latitude, longitude, and altitude of the particular area. The inherent accuracy of GPS is about 5 meters, which based on the 95% probability that position will be given 5 meters of the true value position. Next, uh, this is the first technology which is basically used for horticulture crops in big orchards or big farms. This is variable rate technologies. This is the techniques of applying farm inputs in varying rates at the place and amount they are required to produce uniform yield throughout the field. Involve great soil sampling and variable rate fertilizer application, development of application map. Computer uses the map and GPS received to direct to product the deliver control. Basically, it's component of two things as computer or the flashcard with the field precision maps and feed controllers are just a controlling point for all these variable rate technologies. These are some soil sampling data for the estimation of nutrient estimation in different area. Uh, this is from the uh, Karnataka field. This is spatial variability in the available nitrogen like phosphorus, potassium, and micronutrient. Based on map data, we mapped the particular area for the nutriency, deficiency, and sufficiency area of the particular nutrients. And we process these images for calculation of data for fertilizer application and other estimation for the future needs. These are some the photo prediction of particular area for the map. Please next slide. These are some photographs which is like prediction of different uh, nitrogen, phosphorus, potassium, and micronutrient deficiency in particular area. Based on these maps, we predict the particular area for nitrogen deficiency, sufficiency, or stress zone in particular area. These photographs or these mapping images are used for calculation of data for particular fertilizer application and as well as of an additional data for future needs. Next, these are some GPS-based information system. Uh, this is the application of GPS, like what type of soil, boundary mapping, then soil pH estimation, nutrient level in soil, pest or disease pressure in particular area. We calculate all these things based on this imaging or GPS imaging for estimation of data. These are the prescription map and applied map in particular area. Firstly, we use these maps for particular area, like mostly NDVI, based on NDVI index, we calculate all these points basically in precision farming and in other particular system for mapping system in different horticulture crop or fruit crops. Basically, it's based on the NDVI index. We calculate the healthy area, greener area, or stressed area uh, in particular point or particular area. Next, these are some specially designed variable rate application equipments. This is basically used in big farms. Currently, they're not used in India because we have not as much big farms for controlling all these things. We have a small pouches of patches of particular crops and all these things. Then these are the only equipments used in variable rate technology developed till now, and we have dynamic applicators, dry fertilizer spreader with 3i setup, and variable rate liquid applicator, then fertilizer spreader are also used. These are the specially equipped uh, e- equipments. This is basically used in uh, uh, fertilizer application and related to nutrient management. Then VRT fertilizer also using this type of training system in different fruit crops, simply based on canopy volume, or based on canopy volume, we apply fertilizer based on mapping and canopy value. This is the application map for the particular area or particular for the big farms. And based on this mapping image, we calculate the particular uh, fertilizer application in particular field for the uh, application of different fertilizers. Next, the most important things in horticulture crops. This is yield estimation. This is a some experiment on yield estimation. The crop characteristics will be used to estimate the volume and density of citrus canopy, which can be related to yield information. According to this GPS or mapping system, uh, the first thing is we calculate the map area or canopy volume for yield estimation. So basically, we focus on volume and density of citrus canopy, which can be directly related to yield information. And yield estimation is critical process in citrus orchard management. If we talk about big farms and basically in quinoa or other species. Then this is a flow chart of the this yield estimation system. We covered the original plot, then we map image of the particular bearing fruit orchards. Then we process these images, the plant region of interest section, tree row extraction, initial tree position detection, and then in optimization phase, we process on position and diameter optimization, or then we identify the trade result for particular area, and based on volume and density of the particular row or particular orchard, we calculate the uh, predicted yield uh, of the particular field. Then the the most important part of this uh, GPS system or plant use of precision farming in stress reduction. Plant stress reduction, either it is avoiding or avoiding stress. Remotely sensing the chelvi infected or water stress trees using hyper spectral or thermal imaging. The thermal image of individual tree under the different conditions, and the average pixel value of the healthy and stressed tree will be calculated for the processing of data. The average pixel value were higher in stress plant than those of the healthy one. These are some data of predicted image for the estimation of plant stress in particular area. Okay, this is the some graphs, the predicted graph for average pixel value for the stress area and healthy area of the plant. This is just the prediction of data for the healthy and disease affected or water stress plant in particular area. This is the thermal image and average pixel value of HLV infected and water stress tree and their comparison with the healthy tree reflectance. This is generally the we calculate in imaging process or in thermal imaging or any other GPS mapping system, we basically calculate the pixel value of the particular area or particular object. If the average pixel value is higher in particular than those of the healthy plant. Next. If we talk about the yield monitoring system for citrus, this is the most important part in citrus. The yield monitoring is one of the main components for precision agriculture. And generally, we focus on two things if we talk about the precision farming. First is fertilizer application. Second is yield estimation. These two things are more important in precision farming. Generally, most of the things are directly related to either it is stress estimation, disease prediction models also there. Then yield monitoring system is also there. And all these things are used in precision farming for calculation of data. If yield monitoring consists sensor like mass or volume flow sensor to measure the volume or the actual mass or weight of the fruit. Citrus fruit yield can be calculated using different formulas, and this providing a single tree real-time citrus yield mapping system developed by Annamala et al. In 2004. The color charge coupled device camera and image capture board, speed sensor, and DGPS differential global positioning system or receiver system are developed for yield estimation. The yield monitor calculated yield by the dividing the crop mass by volume flow rate that is passing through the mechanical harvesting machine for the given time by the covered area. This is the basic things for the yield monitoring system in any fruit crops or any other horticulture crops. Next. These are some tools used in yield monitoring system. We divided this system in system architecture or system component. We divide this citrus yield monitoring system in two parts based on NIR sensors or data logging system or data logger and cell. All these things are related to this yield monitoring system for yield monitoring in different fruit crops. This is the example of citrus, but it is usually used in various fruit crops like apple, pear, peach, plum in big orchard, or specialized with mechanized special training system or like advanced training system with food crops. Then uh, then and then only we use this technology for the precision farming system. Not in old type of orchard system. We generally use in specialized training system in fruit crops and precision farming. This is the two main component for yield monitoring and yield estimation in different fruit crops. Then this is the mapping image of yield mapping for citrus fruit. Next. Yield mapping is the process of measuring the crop yield and integrating with GPS obtain positioning information. These are some maps used for yield mapping for citrus fruit crops in different area. The interpolated maps showing the variation in the yield and canopy volume and NDVI index are used for the mapping of yield in different fruit crops. The expected accuracy of the sensing technology for the yield prediction is 96 to 97% or greater than that. If we use this type of mapping system for yield mapping, yield monitoring system, or yield estimation in different fruit crops. Next. Then we also use for the control of different insect in different fruit crops. Then this is the research of the Moza et al. In 2009. The spot is spraying of citrus tree canopy for controlling psyllids and automatic technique capable of recognizing the new leaves and spraying the pesticide only on those targeted would of great interest to grower by making the spray application economical and environmentally sustainable. A sensing system was developed that could differentiate new or immature form or old or mature leaves on tree canopies based on spectral reflectance characteristic of the leaves. The system consists of the control box, sensor, pump, and solenoid control sphere. And these tools are used for spot spraying of different like insecticide or pesticide in fruit crops. Based on this, the normalized difference vegetation index gave the best result in both the static and dynamic test. This is the basically the game of NDVI index for calculation of anything like related to stress condition, related to yield monitoring system, or related to disease estimation, disease modeling. For everything, generally we use NDVI index for calculation of all these things for the in the precision farming. Next, this is a component related to spray of different insecticide or pesticide in food crops is directly connected with the computer system like control box or all these system related to your spray system like nozzle sunlight valves, GPS receiver, spray pumps. All these things are connected with control box and directly related to the mapping image in particular uh, computer system. And based on this mapping system, they calculate NDVI index and then use for the spraying in different orchards. Next. And this is the most important point for the today's session. This is basically focus on the nutrient diagnosis and management in different fruit crops using remote sensing techniques. Uh, in remote sensing techniques, we use various spectroscopic data for the calculation of calculation of nutrient distribution data or nutrient management in different food crops. This is basically based on the NIR data for the uh, particular process. The near infrared spectroscopic techniques is used in multi-step process. Rapid and non-destructive analytical correction of diffuse reflect NIR radiation with the chemical and physical property of the soil plant component directly related to the particular crop used in remote sensing. This is the flow chart of the remote sensing estimation data for the reflectex measurement, signal processing, statistical analysis of the particular data, and calibrations of data for the particular area, and validation of data using physical property of soil, plant component. Also, we take the physical data as well as machinery data, and we validate particular data for the particular crops. And based on interpretation, we recommend all these techniques for the particular area. These are some uh, advanced application of remote sensing recently that are used in fruit crops on various horticulture or flower crops like multivariate data analysis to predict and measure the nutrients in the fruit crops. Basically, if we talk about the pear crop, in 2017 they developed one technique that we based on remote sensing data. This is the NRI spectroscopy in determination of nitrogen in pear. If we talk about citrus, the citrus is uh, mostly the crop. Most of the studies are done in citrus. We talk about the fruit crops, like measuring of nitrogen, phosphorus, potassium, calcium, and estimation of different micronutrient in citrus based on remote sensing data or NIRI spectroscopy. If we talk about gooseberry, the ATR, FTR spectroscopy used for determination of nitrogen. In most of the grapevines, we use this spectroscopic or remote sensing data for monitoring of nitrogen, starch reserve in perennial tissues of the vine. This is also measure the uh, leaf analysis value, plant nutrient analysis, and soil analysis values. If we talk about the lychee plant, then infrared spectroscopy used for estimation of nitrogen and potassium in lychee, mango, sapota, and other crops. These are some recent technologies used in different uh, fruit crops and validate in different fruit crops for uh, collection of or data or multivariate data analysis and prediction of measurement of nutrients in different fruit crops. Next. This is a non-destructive evaluation of leaf nitrogen constraints by field visual and near infrared scope in pear orchard. This is the advanced method used in pear crop for estimation of nutrients or for the application of nutrient management in different fruit crops, particularly in pear. This is the non-destructive method developed by Zia et al. 2017 in China. This is mostly used in pear crop for calculation, nitrogen estimation and phosphorus estimation in pear orchards. Then another thing is the stepwise multilinear linear Regression procedure is also the prediction of data and calibration of data based on significant wavelength and prediction of nitrogen content for citrus. This research is conducted for real-time spectral-based nitrogen sensor for citrus tree. Diffuse reflectance of leaf sample with the 5 nitrogen application radar was measured in using a spectrophotometer in laboratory environment, and also calculated with correlation coefficient spectrum, the stepwise multivariate regression procedure, and the B matrix in partial least square regression were used to determine the important wavelength, and sub-wavelengths were identified as both SMLR and PLS as significant wavelength for nitrogen detection. This is the basic tools for the calculation or calibration of any data in remote sensing or any type of precision farming data. We calculate these data, we capture these images or calculate these wavelengths and also calibrate with the statistical data for the proper validation of particular data in the particular field. Then this is the real-time spectral-based nitrogen sensor for citrus orchard are used for calculation of exact nitrogen dose, exact phosphorus or potassium dose in particular area. Same thing is used with the banana crops, mango crops, and vegetable crops for nitrogen estimation in horticulture crops. With the use of these techniques, uh, we calculate anything related to nutrient estimation or nitrogen application or any nutrient application in particular area. Next. Then this is the most important thing related to nutrient management. 4R nutrient stewardship approach for the nutrient management. The 4R is a concept developed through the long history of cooperation between the fertilizer industry and scientific community. This is the most important approach for nutrient management. This is given by International Plant Nutrition Institute, IPNI. This is basically based on the need-based fertilizer system or resource or particular rate-based, time-based or place-based nitrogen system. Since at least 1988, application of right nutrient source or product at the right time in right places associated with agriculture sustainability. Site and cross-specific best fertilizer practice are being used using 4R nutrient steward approach for the different horticulture crops. Next. Then this is the fertilizer-based management practice using this 4R steward method. A right product or right source is a balanced fertilization of NPK and secondary and micronutrients. Nutrient form urea, nitrate, ammonium. If we talk about the right rate, the soil testing, yield goal analysis, crop removal balance. This is the most important things in horticulture crop. If we talk about horticulture crop, then we calculate both aspect of fertilizer application in fruit crops. First is fertilizer fertilizer application in the soil and nutrient removal from the special area of the particular fruit crop. If we fulfill the both the demand of the plant, like not nutrient removal and application of soil, then and only we achieve good yield in any fruit crops. Most of the farmers only fulfill the soil needs or just fertilize the soil for the particular crop, not whether about the nutrient removal from the upper area in the form of the fruit harvest or in the form of the pruning boots and all these things. Then we calculate both the things using these remote sensing or precision data like nutrient removal from the plant and fertilizer application in the soil. Then plant tissue analysis. This is the most important thing. Leaf analysis or plant tissue analysis for nutrient estimation in plants or calculation of nutrient removal from the upper part of the plant. And the crop inspection, record keeping, and variable rate application technologies are used for application of right rate in particular feed. And then timing is most important things for the fertilizer application. Then application timing, flow and control disease fertilizers are used for the use in precision farming on 4R steward matches. or nitrification inhibitors are also used. If we talk about the right place, the application method, incorporation of fertilizer, applicator maintenance, and calibration of fertilizer data and application of fertilizer is most important things in precision farming. This is also uh, related with the variable rate application technology in different fruit crops or uh, application of different fertilizer in fruit crops. These are the some uh, some important things are mostly used in precision farming, like yield estimation, yield monitoring system, yield mapping, fertilizer estimation, or fertilizer nutrient diagnosis. All these things are used in precision farming for uh, estimation of and prediction of good yield, and for the calculation of prediction map of stressed plant or diseased plant in particular area. Next, this is nutrient expert technology, which is developed by IPNI. This is nutrient expert is the easy to use interactive and computer based decision support tool that can be rapidly provide nutrient recommendation for an individual farmer field in presence or absence of soil testing data. The nutrient decision support software that use the principle of site-specific nutrient management, SSNM green leaker system. This is use optimal sensor to measure the quantity, the variability of the crop, provide instant uh, site-based fertilizer application for inputs such as nitrogen in the field. This is the most uh, accurate uh, tools developed by IPNI for calculation of data in the field level. If we talk about the different vegetable crops, we also use these tools for prediction of uh, data or yield estimation in different fruit crops. Then precision farming, uh, if we talk about the vegetable farming and vegetable farming, this precision farming is mostly based on two things: reduce stress on natural resources and lead to total quality management in a particular field. Then these tools are also used in uh, vegetable crops, in flower crops also. Next, then these are some important things uh, which are also the precision farming, like water management, fertigation or drip irrigation system, controlled environment structure, surface covered protection, precise space utilization like planting system and canopy management, also the part of precision farming or any other precision system in fruit crops or other vegetable crops. Then development of IPM or INN system in fruit crops. Uh, if we talk about other things related to uh, fertilizer application and related to yield estimation. This is mostly used in big farms or big areas for calculation or yield, not in small farms. Nowadays, IoTs are also there, which is used artificial intelligence also used in different horticulture and uh, agriculture crops for calculation of disease stress, calculation of yield estimation, or any climatic data uh, for the particular area. Uh, and in conclusion, in India or the other developing countries, farmers are marginal. Precision farming requires great land and reduce the input cost by implementing of the horticulture mechanical device which help to ease the work in the field. Agriculture is a dynamic system governed by the several biotic and abiotic factors need to sustain as it is a major player in Indian economy. Though we are self-sufficient in food grain production, there are the several gray areas we need to improving the achieving the evergreen revolution. There is a need to transform low yielding and food production system into high yielding ones, that is the convergence of the agro techniques, mainly production related things. like biotech productivity related or space related and GS related things are need to improve. And translation of remote sensing data, GS techniques, precision farming, database information, the implementable scheme and benefits is still remain in the field level, and absorption of technology at the grassroots level by the actual getter challenge. These techniques would be infiltrate into the agriculture sector at micro level for the greater and sustainable benefit. Thank you. This is from uh, my side.
Thank you, sir. On behalf of the team SAAHAS, I extend my heartfelt thanks to Dr. Shivendu Pratap Singh for having enlightening us a lot about the precision farming. So thank you, sir, for the dynamic presentation at the grassroots level on precision farming pertaining to horticultural crops, which not only helps us attain the sustainability, but also it was the need of hour for all our participants. Thank you very much, sir.
Welcome. Thank you so much.
Now I request all the participants to post up your questions in the chat box. The session is open for discussion now. So there is one question from Aman. Please give some light on IoT concept.
IoT is basically a mixture of all these things for. Hello.
Yes, sir, you're audible. You can continue.
Yes. IoT is more in nowadays. IoTs are the part of artificial intelligence. Mostly used in particular area based on climatic factor. This is a IoTs are basically used in calibration of climatic factor, like basically used in disease estimation in different horticulture crops, like prediction of particular disease in particular areas based on climatic. This is the pre-designed data model for calibration or prediction of any disease development in particular area. These are mostly used in horticulture for disease prediction.
Okay. So the next question is from Dibya Jyoti Mahanta. The graph you have shown was not clear, sir. Can you explain it again?
Okay. Please move the slides on graph area. These are some image. These are some mapping image used for calculation of data. This is based on the NDVI index. The NDVI index is used for estimation of chlorophyll or disease affected particular plant area, and mapping of that area uh, is a calculation with the NDVI index. We map particular area for yield estimation or stress related data or any nutrient related data in particular area. Like two type of color or two type of map is used in particular fruit crops based on NDVI index calculation.
Okay.
Previously, I think participants are study about NDVI index. That's why I not explain too much about the NDVI index for the mapping images.
Okay, sir. Thank you. The next question is, sir, can you you explained the spot spraying. Can you please elaborate what is that?
Spot, I talk about the spot spraying in citrus or the tree canopy for controlling of silage. This is a one type of insect for this is the most devastating insect in the citrus crop. This is also spot spraying means spraying of particular area or affected area based on NDVI index. Again, it is calculated based on NDVI index. If particular area is affected or particular area is stressed with particular thing, then we use spot spraying of different insecticide or pesticide in particular area. It is already predicted, already showing in the map a particular area is affected with insect, or some stress plants are there, either from the insect or any pathological region or any nutrient deficiency showing in a particular map based on NDVI index. If we uh, if we calculated the NDVI index, then only based on NDVI index value, we can calibrate the map data. Then we validate the particular machine or particular area for the spraying in particular area. That is spot spraying. We select particular area for spraying or affected area for spraying based on based on mapping image or NDVI index.
Okay. So moving on to next question. Sir, can biosensor be used for biotic and abiotic plant stress management?
Yes, sensors are there for the calculation of data. Various sensors are there for calculation of all these things. Basically, remote sensing is based on the sensor-based techniques like spectroscopy, NIR, MIR, or hyperspectral imaging are calculated with the sensor-based system only.
So the next
Yes, any
question.
other? Yes.
Can I know the technologies developed by Israel for precision farming or sustainable farming?
Mostly, if we talk about Israel, last year I visited Israel for a 15 days training program. They are mostly use all these precision techniques in horticulture crops. Especially if we talk about the orchards area, they use sensor-based harvesting, sensor-based like remote sensing-based yield estimation, mapping-based yield estimation, and spraying in particular field. All these techniques you observe in Israel fields.
Okay.
Basically, all these are mapping images, calculation of average pixel value of particular image, calculation of NDVI index, calculation of any stressed or particular things. If we talk about the harvesting of any produce from the plant, color-based sensor are also there for harvesting of fruit crops, especially used in apple crops. Color detection is there. Sensors or machines are detect the particular color for harvesting of apples from the plants. Or mostly used in apple and citrus crops. They used all these things for the used in all these things in the precision farming.
Okay. So the next question is, can we go for precision farming on orchard level management? Will it be economically feasible?
I already told it is only feasible in the big farms, because machineries are big, machineries are costly, rate of calculation of data is also costly. Then it is only possible with the community farming or large acreage or big farms in the India, not in small patches of the particular land, which is not viable with the mostly most of the Indian farmers are marginal farmer, a small farmer. Then this is not used for the Indian condition.
Okay. Any other questions? Sir, you are getting lot many of comments that the presentation was very good.
Thank you.
So there is one more question from Asha. What are the drawbacks of sensor-based farming?
Drawbacks are related to the lack of knowledge of this sensor, and again we go for the repairing of these machineries, and this is not uh, this is the only drawback in this sensing technology or this sensor based technology.
Okay. So this
Because
was
correction of various things is not possible in Indian condition, like repairing and all these things are not possible in India. Most of the technologies from the outside the countries. Then we go for the particular small things, then we go for the other countries, and extraction of data, machinery, and all these things. This is not possible in India.
Okay. So this was all about the question and answer session. Discussion session is now over. There are no other questions. Thank you, sir. On behalf of the team SAAHAS and all the participants, I convey my heartfelt thanks to you for enlightening us a lot about this precision farming, especially relating to all the practical aspects that you have covered. Thanks a lot, sir. It was very wonderful.
Thank you so much.
Thank you, sir.
Thank you, sir.